Hello again, this is Mr. Schoolman, and this is a short tutorial on how to graph these types of rational functions. These types meaning that they're pretty clear on what the translations are, very similar to the vertex form of the quadratic equation. You get your scale factor, you know how you translate it right or left, and up and down. But before we do that, I want to show you on the calculator with sliders how the graph is translated. So here is our rational function, A being your scale factor, B being your left and right shift, and C being your up and down shift. So if we move the B slider, we can see when we subtract 5, we move over 1, 2, 3, 4, 5. And likewise, if we go to the negative side of the slider, so we're subtracting a negative, which means, of course, we're adding 5 to x, and so the graph will shift to the left 5 units. And likewise with the variable on the outside, if we're adding a positive number, it goes up, and adding a negative number, it will go down. Now the scale factor, let's get this down in the right place. Come on, there we go. Okay, so if it has a scale factor of 1 for A, we can see that it goes up 1, over 1, or over 1, up 1, or down 1, back 1, or back 1, down 1. And so we can tell it's your parent function because the scale factor is A. But if we do increase it, let's say to 3, so it has a vertical dilation, and so from the center of the graph of your rational function, which is the origin of your xy plane, you would go up 3, over 1, or over 3, up 1, two positive directions to get a positive 3. And likewise, you can go down 3, back 1, and back 3, down 1. Two negative directions is a positive, in this case 3. And if we move this over, let's say to -2, it reflects over, and also from the center of the graph, again at the origin. But this time we can find our points of dilation if you go over 2, down 1. A positive in a negative direction is a -2. Or down 2, over 1. Up 2, back 1. Back 2, up 1. And so that all four of those give you a -2 dilation. Now back to the graphs. So looking at these ones here, so let's say we want to do our left and right shift first. So +2 would make the graph go to the right 2 units, and so our vertical asymptote would be, let's get this straight, that's good enough, and -2 would give us the horizontal asymptote, which would shift it down to. And then if we're looking at our dilation of a +3, let's use a different color. So in this case we would go up 3, over 1, over 3, up 1, down 3, over 1, or back 1, it's two negatives, or back 3, down 1. And so we would have those 4 points for our anchors, and then just graph our positive rational function as you approach the vertical asymptotes. You go through the points, and then you approach the horizontal asymptote, and from this side of the vertical asymptote, as we go up, go through those 2 points, and we get a pretty good sketch right there. Another thing that we should be thinking about is some information about this graph is you want to be able to label or list your asymptotes. So for the vertical asymptote, since it goes to -2, we would say that x equals -2. That's your equation. And since your horizontal asymptote goes through -2 again on the y-axis, we write y equals -2 for that one. So let's do one more. Let's go. Okay. So if we're looking at -1, we go 1 unit to the right for the vertical asymptote. Up 2, we go up 2, right there. Now we're looking now at a -3. So this time from the center of the graph, we starting here at 1, 2, we would go down 3 over 1, or over 3 down 1. So it's a positive and a negative direction, giving us a -3. And likewise, we would go up 3, back 1, and back 3, up 1. So we would get those 4 points. And again, graphing our function, it would look something like this, going through our points of dilation, and also listing these x, since x goes through 1, the vertical asymptote is x equals 1, and this one, since your horizontal goes through the y-axis at 2, we write it as y equals 2. Thank you very much, and look forward to the next video where we'll be looking at these same graphs with concerns about the x-intercepts. How do we determine what the x-intercepts are? Thank you.